All right, practice problem number 2 associated with sample problem B. Now, I already have some writing on here because I tried this already, and then I psyched myself out, and I started talking about solving a different problem that is not this one. So, just so you guys know, vectors include magnitude and direction. If you're going to solve for the magnitude, use the Pythagorean theorem. If you need to solve for the direction, use the inverse tangent function, but we don't have to do that here because we already have magnitude and direction. Aha! So, good thing I caught that. That'd have been pretty silly. But the question here is, what is the magnitude, specifically the vertical component of the velocity of the plane in item 1? Now, if you need to double check my work, if you need to fact check me, you can check the previous video in this playlist. But if you're going to take my word for it, we had a situation in which we have a plane traveling with a velocity of 105 kilometers per hour at an angle of 25 degrees above the horizontal. And in item 1, we solve for the horizontal component of the velocity, right, the x component. And in here in item 2, we're being asked to solve for the y component, which is the vertical component. Now, let me describe the thought process here. So I'm looking for the velocity specifically in the y direction. Now, I need to deduce this information based on the overall velocity, like the total velocity. So I'm going to multiply that velocity by here it's the sine, okay, the sine of the angle. Now, if you watched item 1, again, the previous video in the playlist, you might be thinking, okay, well, last time you used the cosine of the angle to solve for the horizontal component. This time you're using the sine. How do you know which one to use? Because remember, your rule SOHCAHTOA. In item 1, I was being asked to solve for the x component. Again, relative to the angle of 25 degrees, I'm going to use the adjacent over hypotenuse. Okay, adjacent over hypotenuse. And so in this item 2, I'm going to be using opposite over hypotenuse. Therefore, I use the sine. That might be useful. If I was going to, let me show this for you. You don't have to take my word for it. So sine is equal to opposite over hypotenuse, right? Well, here I'm actually being asked to solve for opposite. Okay, so if I'm going to solve for opposite, I need to get hypotenuse on the other side, so I'll multiply both sides by hypotenuse. So I can see that hypotenuse is canceled over here, so I'm left with opposite is equal to the hypotenuse multiplied by the sine of the angle. Well, the opposite here is the y component of the velocity. The hypotenuse here is the resultant, right? The total velocity. And then sine, obviously the sine of the angle. So I'm not just pulling this out of thin air. I'm using your basic trigonometric functions. Just realized that I didn't show you this in item 1, so it'd be a good time to show you here. But that's how we get this set up here. Again, sine because it's the opposite side over the hypotenuse. So let's start plugging some stuff in. So we're going to have 105 kilometers per hour multiplied by the sine of the angle, which is 25 degrees. And my calculator spits out a whole bunch of stuff, but I'm going to use two significant figures, and report 44 kilometers per hour. Okay. Now, I will say you want to be very, very careful here. Technically speaking, you don't have to do this because the question directly is saying vertical component. It's only wanting vertical component. So if you're talking about anything but vertical component, you're the weird one. But you don't want your test score, your grade, to be dependent on how cranky your teacher is, right? And so what you want to do is any information that you have to give that is accurate, you want to give that. And so if I were you, I would be safe. knowing that again, velocities have magnitude and direction, I would include the direction. Now, you don't have to, because this says directly magnitude vertical component. Okay, the question actually is telling you you don't have to do direction. Just scalar, just magnitude. Okay, but if you want to be safe, I'm sure not going to mark you down for adding that it's in the vertical direction.